Good afternoon. My name is Randall Sherman. I am the owner and the president of a boutique consulting firm, market research and consulting, named New Venture Research. And we have been tracking the electronics industry for well over 20, 25 years. And we've sort of specialized in this sector by trying to quantify and measure it, as well as understand the segmentation. So we've produced I guess a seminal report, you might say, called the Worldwide Contract Electronics Manufacturing Market. It's essentially tracking the trend of outsourcing. We also have a look at the total electronics market, the OEM electronics market, which is essentially the TAM, the total available market that's available for assembly, of which contract manufacturing is a subsegment and embedded computing is a subsegment. But we also, we're interested in other areas that are emerging, things like printed electronics. I'm going to touch on that just a little bit today. We go so deep as to look at nanotechnology. There's some interesting examples in that are impacting the electronics field. And we also track advanced IC packaging, things like 3D integration and stack packages and so forth. Sort of looking back in time, we sort of got in on this trend early in 1993 when the EMS industry was just taking off. And it's been a wild ride. And it's been one of the largest transfers of revenue from the OEM side to the subcontracting side that's ever occurred. Right now it's well over 300 million in the last few years. So it's definitely a business proposition that works, but today the EMS industry only controls about 40% of all the spend. So there's another large segment of about 60%, which is still being done in-house. So what is that? What's missing here? A lot of it is assembly work that is not necessarily outsourceable because of the complexity, because of the volumes, and because of the preference. It's very popular in North America and in Europe, but you go to Asia, and people there like to build stuff, and they don't like to subcontract it. So there's a lot in Japan still, there's a lot in Taiwan, China, and Korea that is still being done in-house. Now, Japan and some others are sort of coming along, and they're gradually outsourcing a portion of what their assembly build is, but there's still a lot available that's not come through yet. We decided to look at the embedded computing market as well. We've done this for several years. We produce a report biannually, and we take a look at all the market segments, and we break that down by a good 20, 30 sub-product segments. So we drill into industrial, and I'll show you a few examples of that, and medical, and of course defense and aerospace. A little overview of the structure of the industry here. We all know about the OEMs out there that are building and requiring new assemblies, and it's the largest portion of the pie. And these assemblies come in at a certain cost, but it also has a development side to it as well. Contract manufacturers have come along, and they often come in at a lower cost, but they're no longer doing the design, or at least not now. And there's a new player in the industry called the ODM, Original Design Manufacturer, and this is a bit of a hybrid. So this is typically this started out in Asia, where certain companies like Quanta Computer and Compal Electronics had their own branded product, but they would also do contract manufacturing. And this eventually rose to be a pretty significant number. Now, in a sense, I almost think like the embedded industry is a bit of an ODM. They have their customers, they have their own products, but they also do contract manufacturing. So it's sort of a niche here. but it's evolving. And the real question sort of comes down to design. Who owns the design? Who does that? And the contract manufacturers see that as a really significant opportunity, because when you control that, you control the assembly and you control the supply chain. So contract manufacturers, they do two things really well. One is that they solder, and the other is that they control supply chain. So to do that, some of the larger ones, which I'm sure you know, Flex and Jabil and Foxconn, they're starting to develop these innovative design centers. Jabil's is called Blue Sky Innovation Center. And it's very impressive. I mean, they've poured significant resources into this. And they have everything going from 3D printing, printed electronics, to all kinds of amazing tools and placement technology that is no longer in the domain of the OEM. They're so far ahead of the OEMs and most other companies in this regard that they're really offering a significant value proposition to the industry. We have a newsletter called the Manufacturing Market Insider, which tracks the EMS industry every month. And we took a look at Silicon Valley and what's the footprint in Silicon Valley of the contract manufacturers. And it's significant. It's like 4 million square feet. And so we did some interviews with the people, the companies themselves, like Jabil and Flex and others. And they said, yes, this is really working. We are really getting the customers coming in. They're showing us some really cool stuff. And so they feel like that they're reeling this in, and that this is sort of the next step in terms of the evolution of the industry. Because the OEM has essentially lost its ability and desire to build things. They just want to design it and sell it. So any new startup that comes around these days doesn't even think of building their own manufacturing operation. First thing they do is they select a contract manufacturer, and if the contract manufacturer selects them, they've got a good head start on getting their product made. So that's just the reality of the situation. So digging down a little bit deeper into the structure of the industry, we've got a number of trends. So initially, the tier one contract manufacturers really only interested in volume. They were taking over motherboard assemblies, mobile phones, pretty much anything that the OEM would throw away. And it's interesting because the strategy was, we'll just grow revenue. And if you've got a certain earnings per share from that revenue, as long as the top line is growing, the bottom line is growing. And that's what drives the stock price and the valuation. So that worked for a while until companies like Sanmina showed billion-dollar losses 5 years in a row. And they started getting a little bit smarter about what kind of assemblies they would do. So a lot of the throwaway junk they stopped doing. They basically just let it go back to China, because the Asians, as I just said, like to build this stuff. But in a way, they're almost their own worst enemy, because they'll take anything. And sometimes they'll take things that are not profitable, that go right down to the margin. And so essentially, they compete themselves out of existence. So they haven't really, I mean, there are some successful ODMs over there and OEMs as well, but it's a little bit of a different approach. When you come here, the contract manufacturers are getting smart, they're picking their customers, they're taking those assemblies, those contracts that they can make money on. And in fact, one of my colleagues, who was from one of the early incarnations, this company's called Selectron before Flex bought it, and he was marketing manager there, and he said his main job was to decide who not to keep. Which customer do we get rid of? Because it was sort of a cost analysis benefit that they went through. And so they started getting smarter, and today they are entering your space. They're very keen on this, and they've got big resources. And you're going to see that you know, there's even companies like Sanmina has a VP of embedded systems and development. And so they're really starting to target this. And in a sense, you guys, these companies are smaller, are going to be potential targets for them, you know. So you have your place in this space, but you've got a lot of competition. So the advantage that the EMS companies have is they've got tremendous investment in the manufacturing technology itself and the process technology. And the OEMs, they don't want to continue to invest in that because it's often you're following the leading, bleeding edge. But if you're a contract manufacturer, you run your lines 3 times a day, you know, 7 days a week, you know, an hour off for maintenance. And the old OEMs were usually just one shift, 1 8-hour shift, maybe a shift and a half. So you can kind of see that once you start leveraging all that SMT equipment, that you're getting a much better return, and plus you know you're doing it for many customers, so you have a lot of good technical knowledge on how to compete in the industry. So what it's led to is a much more verticalization of companies in this space. So you get companies that simply or strictly want to just do industrial design and products, or medical. Medical is a good one because it takes certain certifications, and so does aerospace and defense. So once they become expert in that, then they become a much more attractive solution for the OEM customer. And I think you guys follow this model as well. It's interesting that today the OEMs really have lost their ability to manufacture. They're no longer investing, they're relying on their partners. And these companies have deep resources or deep connections with the OEM customer. And engaging with an EMS company is like getting married. It's very difficult to disengage. I mean, you really have to mess up to get fired. But there is shakeout. And, you know, we're not going back. The OEMs are not going to be building their things, except for some of the prime contractors and so forth. And there's certain products, for example, in the medical industry, where they've got class systems, where class 3 is life support systems. So the OEM, in this case, does the final integration, does the functional test, does the systems integration, but they outsource the boards. So, and it's usually under pretty strict requirements. So, yeah, so that separation has happened. That's not going to be coming back. Okay, so let's look at what sort of products, what sort of outsourcing is taking place in the industrial product area. Well, we looked at about 350 of the largest OEMs worldwide and drilled down into what their industrial product offering was. And it's mainly relying around programmable logic controllers, but in the industries, in the construction, the agriculture, mining industries and things like that, you've got some really interesting boards and systems to be assembled. There's lots of other examples. I mean, just think of the process industries themselves, the production process. All of those need industrial computers. And the embedded industry, this is really a very rich area for you. But as I said, the EMS guys are invading this and doing more and more of it, although they're being a lot more selective. Test and measurement is another good segment in the industrial product area. There's a lot of capital equipment is a big one, semiconductor capital equipment, test hardware inspection, metrology, things like this. There's some really, really complex builds, some great opportunities. There's almost a perception here. It's when you look at the embedded industry, there's not many companies, more than a couple hundred million. maybe, yeah, around that 200 to 300 million. There's not, you won't find that many, but what you're starting to see is companies like HP and Dell coming up with their own embedded solutions and product offerings. So there's a lot of competition coming in from the big guys, making it tough on you. There's other miscellaneous industrial applications. We consider ATMs and kiosks, vending machines to be in that area, but there's some pretty good contracts that are attractive. And then it gets down into the lighter stuff like HVAC and appliances and things like that. And most of that is just being returned or at least ignored and goes back to Asia. So it's probably not the sort of stuff that gets your attention. And then there's the clean energy sector, which has got some really interesting things. Mainly it's inverters and electrical control and power supplies and stuff like that. Okay, medical industry, as I said, has this class system of oversight where class 1 is the least severe, and class 3 being the most important, the most regulated. So, but there's lots of stuff in the medical industry. You've got your MRI machines and your X-rays and tomography and dialysis, oncology, all this. A lot of this is, the high percentage of this is outsourced to the contract manufacturing industry. Although I know that embedded guys also have some of this too. Therapeutic areas, a little less in terms of hardware and percentage. I mean, if you look at some of the medical diagnostics equipment, you've got a high proportion of hardware and build, and whereas with the therapeutic, you've got a bunch of, mechanical systems and things like that. But it's still a significant segment. And then there's monitoring and surgical, which is a very attractive area. So you've got a lot of cool equipment out there. Some of it with some volume, and it's constantly changing. It's got a good future for it. All right, so I'll just put this up here. You can read it and get it later. It's basically what I've been talking about how the EMS value proposition has been a successful one. As I said, the Asian community model is being challenged mainly because they drive themselves into extinction often, but they're still doing a lot of work out there, and they like to do it. And that's not going to change. Okay, the industry will stay highly concentrated, but mergers and acquisitions is going to be a big part of the future as they look for not just technical capability, but your customers. They want your customers. Okay, so here's just some trends to watch. Printed electronics has got some interesting things. The nanotechnology, I'll give you a quick example of that. As you well know, in the memory market, DRAM is very fast, but it's volatile. Whereas flash memory is non-volatile, but very slow. So a new type of NRAM technology has been invented with the nanotechnology, and it's not only fast, but it's non-volatile. And they're using nanotechnology to do this. So that could really reset the industry here in a few years because they've already got it implemented in a number of fabs. A lot of stuff in thin films going on that you need to watch. Even the board of bare board assembly is PCB boards is changing, and its technology is going to thinner and smaller direct attach boards that you can just directly attach the chip. And Samsung is leading the way in this. The next generation on the Galaxy S9 is using this new bare board technology. And so that market's gonna really change over time. Okay, EMS will continue to be the engine that drives the growth for the next decade. Partnering with EMS and OEMs, companies will seed the technology innovation to be more synergistic in the future. And I think embedded computing companies will continue to survive in their niche, but ostensibly be threatened by the large EMS and OEM companies that want to be in this space. And this is often how I wrap up some of my talks. It's his favorite quote. It's not the strongest that survive, nor the most intelligent, but the ones most responsive to change, by Charles Darwin.